So I've been meaning for a little while to do a screencast to show why it is so useful to use JCAMP, and specifically JSpecView, to look at your NMR spectra. Here's an example on experiment 42, which is an experiment that was done recently by my grad student Khalid. This is on the Useful Chem wiki. And it involves basically mixing phenylacetaldehyde with t-butylamine, trying to monitor the formation of the resulting imine. Now, what makes using JCAMP so useful is that you don't have to take a whole bunch of expansions to get the information that you need from the spectra. Let's take a look at this phenylacetaldehyde, for example. We basically just have a single file on HTML, and when we click on it, you see that the spectrum pops up in a little applet. And we can do a lot of things to this without needing to look at different printouts. For example, if I look at the aldehyde peak, I simply have to left click, drag, and where I want to stop, I can see that this expansion happened. So I can expand this spectrum all the way to see that triplet very clearly and be able to take differences between the peak positions to get J constants, for example. Now, if we go back to the original spectrum, we're going to clear all the views. We can also do integration. So to do the integration on JSpecView, we right-click, we view, and then integrate. And we can modify these factors to make it look prettier, but let's just use the default. And we see this yellow integration line. Now, again, we can expand any area that we want. So if we look at the CH2 group, for example, this is phenylacetaldehyde that we're looking at. We can expand it. We can see that the integration can be calculated pretty easily. On the top right corner, there are two numbers that are giving you your position at all times of the cursor. So if we look at the top of the integration, we're looking at roughly 125. Right? And underneath is 105. So we're looking at about 20 units for two hydrogens. Okay? So now we will zoom back, clear all the views, and we're going to expand the aromatic region. And again, we can subtract the two numbers. So this integration ends at about 105 and starts at about 55. So we have 50 units for 5 hydrogens. Again, we have about 10 units per hydrogen. We'll zoom back, clear all the views, and look at the aldehyde area. So now this one has about 54 minus 48. So we're looking at 6 units that is supposedly representing one hydrogen. So there's a problem with the integration in this spectrum, and I am putting this up as a question out there to try to see if anybody can actually answer me as to why we're having an integration discrepancy with this spectrum. So this brings up another really useful aspect of JCAMP, in that all of the parameters of the NMR experiment are automatically recorded. So in JSpecView, to see that, we right-click, and then we look at View, Show Header, and we can see all the parameters here. So we can see that this was done on a 300 megahertz machine. We can look at the number of scans and just everything that was done for this experiment. So now we can monitor what happens when we mix phenylacetaldehyde with t-butylamine. So we'll go back, and there are a number of spectra here. If you look at the logbook, most of them have already been linked, but we'll just take a look at the very first 5 minutes after mixing. So again, we click on this link, and we have in JCAMP format. So let's take a look at some of the new peaks that are coming out after 5 minutes of mixing the aldehyde and the amine. Well, we still have our aldehyde, original aldehyde triplet. We'll zoom back out. And we can see in this aromatic region, a little bit downfield from there, we have a few more peaks that are popping up. And I want to focus specifically on this little triplet here that's coming up. So if I magnify this, I can see that it's coming in at about 7.65, and I can measure the coupling constant, which is 5.3 hertz in this case. I can then zoom out, all right, because I'm thinking that that triplet may be the imine proton that will be coupling with the CH2 group. So if we look elsewhere in the spectrum, a little bit more upfield, we see that we have another little doublet that's popping up. And this doublet is around 3.57. And again, if we calculate the J constant for this doublet, it's 5.3 hertz. And so there is a good likelihood that those two peaks are representing our imine that we're trying to form. Let's click back to take a look at the molecule that we're talking about. Okay, so we're talking about the imine of phenylacetaldehyde and t-butylamine. So it turns out that this reaction actually does not end up being clean. If we take a look at what happens after 42 minutes, we see that there is in fact a lot of stuff coming in besides the imine, especially if we look at this region between 2 and 6 roughly. There are all kinds of other peaks coming in. Maybe these are related to some aldol condensations that are happening, but the bottom line is that this reaction is really difficult to do directly like this. So hopefully I've demonstrated with this little example just how useful it is to keep your spectra in JCAMP format. And I gotta have to thank Robert Lancashire for developing JSpecView to enable us to do this. These spectra were very easily converted from their original format on our Varian 300 megahertz instrument, and we actually have a little tutorial on how to do that. If you go to the Useful Chem site, click on the contents page, you'll see instructions here for saving in JCAMP format on the 300 megahertz machine, for example. And that should enable you to do the same thing. So you don't have to spend a lot of time printing out expansions for regions that you're not sure that you're going to need. Just post your file online and let people add it.